Dear Lord, we are grateful for this day. Thank you for our lives. Thank you that you have enabled us to join this program. Father in heaven, as we're going to study, come and be with us. Give us knowledge, wisdom, and understanding, and help us to understand whatever the teacher will tell us. Through Jesus Christ, I pray. Amen.
Amen. Thank you so much. Today we are going to look at linear programming. Yesterday we looked at how we do the graphing, and today we are going to go on and look at how can we now extract the equations from, or what we call the constraints from the word, and then we go on and draw. So that's what we are going to be doing in today's lesson. And our objective is that we must be able to extract and be in position to represent those given inequalities on the graph, and then also be able to identify the required region. So I'm going to ask you to first put down the steps that we need when we are going in for the graphing. So put down those few steps as we continue. So let's first have the steps put down, then we continue. Okay, let me hope you have finished to have the points put down. Okay, but you'll let me know through the chat whether you have finished. So those who have just joined, we are putting those few steps that we need when we are solving any number concerning linear programming. Okay, some people are saying they are done. Okay, done. Okay, we are good to go. Now, what happens or what do you need to know? Whenever we are dealing with linear programming, there are certain things that we are going to be doing. And those things that we are going to be doing are going to be helping us to come up with a solution. The first thing I'm going to talk about is what you call the feasible region. When we talk about a feasible region, yesterday we saw that whenever we do the shading, you'll find out that you'll shade, you'll draw your lines, and after you're going to shade the different lines. Let me say I've drawn my thing and I've shaded like that. So you're going to be remaining with the region. Now, this region you remain with that is unshaded is what we call the feasible region. So the feasible region is that region that is wanted, that region that is going to satisfy your inequalities, that region that you are going to use in order for you to be able to find the solution to your inequalities. That's what you call the feasible region. Then we have what we call the vertex. Vertex, in simple terms, are like the corners. So when you look at the shapes we always remain with, it can be a triangle, it can be a rectangle, it can be a quadrilateral, it can be something like a pentagon. So it can be any shape. But always, you are going to find out, not always, but in most cases, our solutions to these equations or to these our solutions to the linear programming problems always are found at the corners. So whenever you look at that corner, those are going to be your first target points when you are looking out for the solution. So always first aim at the corners. These corners, in most cases, are the ones that have either the maximum or what you call the minimum points. So the maximum is like in case you want to maximize profits. So in most cases, you'll find that the values or the coordinates you have along the corners are the ones that are going to either yield the maximum or to yield the minimum. So those are the first points that you are going to test. However, if you are testing them, then you must ensure that the point, whenever you find that the line you are going to test on is a dotted line, and maybe is meeting with a borderline, then that point will be disqualified, because we say that whenever we have a dotted line, it shows us that that one is not part of the solution. So whenever you are dealing with regions whereby you have only dotted lines, then here we don't expect you to go on and pick these points, because we know that for dotted points, they are not part of the solution. So we do not pick them. Hope that one is fine. Then the next one is that the next one I want you to know is that these points that you pick to be filled in your objective function are what we call the optimal points. So optimal points are those points that you are going to be picking, those points that you are going to be picking from the region that is feasible. So those points are what we call the optimal points. So there are three things you need to know. One is what we call the feasible region. Number two, you must know what you call the optimal points. And when it comes to optimal points, I will always advise that pick at least three or more points. Do not just pick one point and use that point to come up with a conclusion. So pick as many points, as many as 5, 6, such that you can have a big sample space that will help you to know what is my maximum and what is my minimum. And remember, I told you that linear programming always aims at obtaining the maximum or the minimum. And we say that it can be maximizing the profits or minimizing the costs, depending on the question that you are having at hand. Okay, hope that is very fine. Members, are we on the same page? Are we good to start? Kindly let me know through the chat. Okay, people are saying we are good to go. Okay, now let's have our first item. So this is our first item. Someone can read for us. Who wants to read for us? Okay, Bernard.
Morning, sir.
Good morning.
So activity 1 is saying that Mark is planning to buy a notebook. Mark is planning to buy notebooks and pens for his siblings. A notebook costs shillings 1,000 each, and a pen costs shillings 500 each. He has a total budget of shillings 5,000. Mark must buy at least 3 notebooks, and he wants the total number of items, the notebooks and the pens, to be at least 8. Task: write down the inequalities representing Mark's constraints. Represent the feasible region for Mark's purchases on a Cartesian plane. Determine the combination of notebooks and pens Mark should buy to maximize the total number of items while staying within his budget.
Okay, thank you. That is our item that we are going to work on. Now, I told you yesterday or the other day that always the first thing you have to do is you have to define. 2, look through your question. Ask yourself, what are those 2 things that are changing? Those 2 things that are changing are what we are going to be letting as our variables. Then read through the question. The question will always give you the hint, what they want to maximize or to minimize. Put in the chat, what 2 things are you noticing from the question that are changing, that we are going to be letting? And even now, can we even go on and even put which value you are going to, Chisache, thank you. Now, can we even put for me that this is going to be my X, this is going to be my Y? Okay, Hunter, thank you. Now, I want you to put my X is going to be this, my Y is going to be this. Patricia is saying, hey, okay, okay, very good. I'm seeing the people who have put in the chat, I'm not saying that they have put them right. Yes, last time we said that, I always advise that when we are dealing with this, always the first thing they have mentioned, it can be your X. Now, when you look here, they first mentioned the notebook and then they mentioned a pen. So now I'm going to come here and then I'm going to let and use words. So we shall say that let X represent, let X represent the number of notebooks, Mark buys. That is my opening statement. Then I will say let Y represent the number of pens Mark buys. Please, for you, don't put these things I'm putting. For you, write Y represent the number, write the full sentence. Then after that, I told you that you can first summarize your data in a simple table, whereby you're going to have your simple table. In this simple table, you have identified that you have a notebook. You have still identified that you have a pen. So that is my notebook and this is my pen. So you read the question again. So they're telling that they are telling that a notebook costs. So you come here and say, now they're talking about costs. The notebook is costing 1,000 and a pen is costing 500. And what total amount of money does Mark have? The total amount of money that Mark has is 5,000. When you read the question, he has a total budget of 5,000. Then continue and ask, Mark must buy at least 3 notebooks, comma, and he wants the total number of items to be at least 8. So here you say total. So he wants that, so meaning that when you add a notebook and a pen, the total should equal to 8. Now, after that, you are going to go on and ask yourself, do I have everything I need? And then you will say, probably I have. Then continue, first read the question and complete. Then they are telling that write down the inequalities, represent a feasible region to determine markers purchase, determine the combination of notebooks and pens Mark should buy to maximize the total number of items while staying within her budget. Now, members, I want you to let me know now here I'm going to put my costs. Okay, I'll bring my objective function later on. Now, after drawing this table of mine, I'm going to extract. But as I'm extracting, I need to know which kind of inequalities am I going to use. So they are telling us that he has a total budget of 5,000. Members, what did we say? That when someone has a total amount, which kind of inequality do we use? Put in the chat. Which kind of inequalities are we going to use? He has. Very good, Kisachi. Yes, because they have told us that he has a total budget of 5,000. That means that the amount he has cannot exceed 5,000. And whenever we see that it cannot exceed, it means that we are going to use less than or equal to, because the amount cannot go beyond that. So it cannot go beyond that. So I'm going to come and I say now, remember our notebook, we used X. You remember that here we used X, here we used the Y. So it is a matter of, up here. So it is just a matter of us putting here X and putting here Y. So we shall say that our first inequality is going to be 1000X plus the 500Y should be less than or equal to 5,000. That is your first inequality. However, since we are going to be representing these inequalities, after writing it, you first write it, then we can reduce it. Now, when I'm reducing this inequality, what is going to happen? What is going to happen? How do we reduce? Now, we reduce the same way we reduce when we are dealing with how we deal the other side. Take an example. You remember, let me say this is 100x plus 200y and is equal to maybe 5,000. What you do, you notice that everything we have here has a 0. So you can first decide to divide by 100, 100, and 100. Because 100 is a common factor, so these zeros will cancel, these zeros will cancel, these zeros will cancel. Meaning you remain with 1x plus 2y is equal to 50. So the same way you reduce here is the same way you do it. Alternatively, for you, if you want to, you can even first draw your table and say, I have 1,000, I have 500, and I have 5,000. Then you ask, what is my highest common factor? Then you say, let me say, when I put 100, here I remain with 10, here I remain with 5, here I remain with 50. Then you ask, is there any other number that can go through at once? Then you say, yes, 5 can go. Then you say, by 5, what do you get? You get 2, you get 1, you get 10. Then that means that your highest common factor is going to be 100 times 5, which is equal to 500. So meaning that now the digit that the number I'm going to be dividing through out is going to be 500. So what do I do? So the moment now I come here, I'm going to come with my 500. I say divide this by 500, divide this by 500, and also divide this by 500. What are you going to notice? You're going to notice that now this is 0 and the 0 cancels. This is 0 and the 0 cancels by 5, 1, by 5, 2. Then here the 0 is cancelled, the 5 cancels, you remain with the 1. Then here the 0s will cancel by 5, 1, by 5, 1, you remain with 10. So meaning that now we shall remain with 2x plus y. I don't need to write the 1y, but let me first write it. less than or equal to 10, which you can now write as 2x plus y is less than or equal to 10. Members, let me know through the chat. Are we on the same page? Are we on the same page? Okay, people are saying yes. Okay, very good. Now, this is our reduced inequality. But the first thing, please first write the first one. This is the major one. Here I'm showing you because we are going to draw, that's why we need it. So this is the first inequality here that I write. Then I go to the next inequality. The next inequality, I'm going to obtain it from here. Mark must buy at least 3 notebooks. Members, when they tell us at least, which inequality do we use? Put in the chat quickly. At least 3. Which inequality do we use? Very good, Patricia. So here we shall say at least means greater than or equal to. And we used notebooks, we represented them by x. So we shall say here, x is greater than or equal to 3. Very good. Then we go to the last one, number 3. The total. They told us that when you add the notebooks and the pens, the total must be at least 8. So meaning that at least 8 means that the total number here. So I will say when I add x plus y, I must have 8. Now, those are some of the inequalities. Then the last one, you know very well that you cannot have a negative notebook, you cannot have a negative pen. And those are what we call the non-negativity inequalities. So those are the last ones you will add. So here I will say non-negative quantities. Now, since here I'm talking about in terms of books, they will be in terms of quantities. So non-negative quantities. So in case you want, you can say non-negative inequalities. And those ones we know our x will be greater or equal to 0 and our y will be greater or equal to 0. Now, these are our inequalities. Number 1, 2, and 3. In case you want, for you even you can go on and like label them and say my first one, you can say cost of buying. That is my inequality. Then you say here, you say at least 3 notebooks. Then here you say my third one, total number of items, something like that. That is very fine. But those are the inequalities that we are going to be plotting. Members, are we on the same page? Yes. Are we on the same page? Marka has said yes. Bernard said yes. Daniela says yes. Okay, very good. Okay, I think now we can continue. Now, we are going to go on to the next one. Now, the next step, it requires us now to go on and plot because they want us to represent the feasible region for Mark as purchased on a Cartesian plane. Now, when they tell us to represent, it means that they expect us to draw. What am I going to do? I'm going to get my equations. So members, can I go to the next screen or you are still writing? Let me know. You just say, wait. You can tell me to first wait, such that you can write or we can continue. You let me know in the chat. Okay, okay, okay. Let me wait for some few minutes. Okay. Okay, let's be writing quickly. Yes, Chilabo. Non-negative quantity, it means that you cannot have negative notebooks. You cannot have negative pens. That always you will have something you have to buy. So you cannot have negatives of them. So that is the meaning. In other words, you cannot have your answer and you go out proud that I had a negative pen. So here we are not dealing with borrowing, that you go to the shop and you borrow. We don't deal in borrowing. We want you to buy. Okay, I think we are good to go. Those who have not yet, just have a screenshot somewhere. Okay, we go to the next page. Now, the next page, we are going to start. Now, we have our inequalities already, and our first inequality we have, since we have already reduced it, is 2x plus y less than or equal to 10. So we say the first thing you have to obtain its boundary line equation. So I'll say my boundary equation is going to be, we say those who were not here, we just remove the inequality, we replace with unequal. So it will be 2x plus y is equal to 10. And we say that we must know the nature of the line we are going to draw. Members, what is the nature of the line? What is the nature of the line? Put in the chat quickly. Very good. It is a full line. Very okay. Now, the nature of this line, it's going to be a full line. So after we said we come up with a table, so I'm going to come up with a simple table where I have x and I have my y. And we say that when I have my x and y, we use the intercept approach where we said you first say when x is 0 and when y is 0. So our equation here we have is 2x plus y is equal to 10. So you start when x is 0, so I have 2 times 0 plus y is equal to 10. This is 0 plus y is equal to 10, and my y will equal to 10. So here I'll place 10. Then I go to the next one, 2x plus y is equal to 10. Now I substitute what happens when y is 0. So I'll say 2x plus 0 is equal to 10. So I'll have 2x is equal to 10. So since I want x, I'll divide by 2, and my x will equal to 5. So here I'll have 5. Now, the moment I have the intercept, those 2 points are just enough for me to draw my line. So I'll extract them. I'll say this is 0, 10, and then the next point is going to be 5, 0. But yesterday I said that for me, it is always a good practice. What I finish is what I draw. So allow me now to go on my graph, and then I first draw that particular line. So on my graph, let me use red. Okay, I'm going to use red, and I'm going now to draw. Now, what are the things that you need? Now, let me first draw. So that is my line. So also draw yours. This is my second line, like that. Then after drawing my lines, I'm going to label them very well, like that, like that. Then I know this is my y-axis, then this is my x-axis. Now, please, let us start now fetching the marks. Now, the first one, when you are drawing a graph, please, you must have a title. Qualities of a good graph. Let me start putting them somewhere here. Now, a graph, you must have a title. So now, what is our title? Our title must be a speaking title. What are you drawing? And what are you showing on your graph? So on our graph, we are showing a feasible region. So we shall have our graph showing the feasible region between the number of notebooks and the number of pens. So that's going to be our title. So I will say a graph showing the feasible region. I can say for markers patches, that is okay. For markers patches. For markers what? Patches. Alternatively, you can say a graph showing the feasible region for the number of notebooks and pens bought by Mark. Number 2, on graph, we must have a scale. Now, your scale is what is going to represent what you have done. So now here I'll say my scale. Then I write vertical. Now, on the vertical, you go back and ask yourself, what did we let for our y? Our y was number of pens. So I'm going to write here that number of pens. Then here on the horizontal, x was the notebooks. Here I will say number of notebooks. Now, what we are doing, we are earning something already. Then I'll come vertical scale. Now, check out the data you have to plot and then ask yourself, now, according to mine, I'm going to use 1 centimeter. So I'll say this is 0, 1, 2, 3. This is 4, 5, 6, 7, 8, 9. Now, for me, you'll forgive me. I'll even have my 10 up there such that it can fit. But for you, you know it can fit very well. Then here I'll have 1, I'll have 2, I'll have 3. Still, I'm starting from 0. I want you to look at how I'm starting my axes. Yeah, because sometimes you may start on different scales. 3, this is 4, this is 5, 6, 7, 8, this is 9. Yeah, that is a good practice. But always it is a good practice. Don't enter into the x-axis. My graph is small, but yours should fit. Now come on the vertical scale. Then you are going to say 1 centimeter represents 1 notebook. Pay attention on that. Because this is 1 centimeter and it is 1. So 1 centimeter represents 1 notebook. In case here you had said 0, 5, 10, 15 like that, then you would have said 1 centimeter represents 5 notebooks. Come here now, write the horizontal scale. Horizontal scale, look at your scale. You can still say 1 centimeter represents 1. Oh, sorry. On the vertical, we have pens. Yes. Allow me to first remove. These are pens. Sorry about that. Okay. So 1 centimeter represent 1. This 1 pen. And then on horizontal, 1 centimeter represents 1 notebook. Members, can I know through the chart? Is that fine? Are we there on our labeling? Is the labeling fine? Very good. Now, the moment you do like that in labeling, even I want to let you know, even when you are caught up by time, label your graph like that. You cannot go out of the paper with nothing. Yeah, make sure your graph is very labeled very well. You'll have something you'll earn. If for any practical you do, even in the physics, first label your graph very well. Though in physics, we don't need to put the scale there. But first label your thing very, very well. Now, after labeling like that, we are going to go on and do the plotting. Now, what am I going to first plot? 0 and 10. Like I've told you, my graph is a bit small, so just forgive me about that. But now for you, I expect you to have 1 and 10 clearly labeled. Now on my graph, I have 0 and 10. So 0 and 10 is going to be here, up here. Then I'll have 5 and 0. 5 and 0 is here. Then what I do, since we said this is a full line, I'm going to get my ruler. I'm going to get my ruler and then I join those 2 points. I join here and here, like that. Then that is my line. After drawing my line, the next thing, before I go in to do another thing, before I label it, because I don't want to label it and then afterwards I don't know how to share, where to write the equation, then I'm going to look out for the shading. So we said that you can first label and say, this is my AB. Where can I choose? I'm going to write here. You write here that testing now. Testing for the region. So we are testing for the region. Ask yourself, members, choose for me one point you want, either in A or B. Either in A or B, choose one point, drop it in the chat. The first point to be dropped is what we shall use in the chat. You can either choose in, Patricia was the first, 2, 2. People are saying 2, 2. So when you look at 2, 2, is a point here. So it is in A. So I'll come and say 2, 2. I write my inequality. 2x plus y is less than or equal to 10. I substitute. This is my x, this is my y. So I'll have 2 times 2 plus 2 less or equal to 10. So 2 times 2 is 4 plus 2 less or equal to 10. Then I say 4 plus 2 is 6 less or equal to 10. Then I ask members, does it make sense? Is that region the wanted and unwanted? Put in the chat. I want to see. Is it wanted and unwanted? Such as said wanted, Chilabo says wanted. Very good. We say that since this inequality makes sense, it means that side you have chosen is the wanted region. Therefore, we are going to get and then shade the other side. So we shall shade our graph like this, like that. So I shade like that, like that, like that, like that. Then I'm going to come and I write my equation, 2x plus y is equal to 10. Please here write an equation, do not write an inequality. So I label it that is my equation. Okay, now that is the first thing. Now we have finished. So we have finished the first one. I'm going to go to we have finished the first one. Now we are going to go to the second one. Okay, now the second one we are going to go to is going to be our next one, number 2. Sorry. We are going to go to the second one. I don't know. The second one, what I'm going to be calling number 2, our second equation. Our second equation we had was x plus y is greater than or equal to 8. Now, since that is our, allow me to first move these letters now. Okay. Now, our next one is x plus y greater. So our boundary equation is going to be x plus y is equal to 8. Then still, I'm going to come up with a simple table. Now, in my table here, still I write x and I write y. I say when x is 0, I'll come in my equation, x plus y is equal to 8. Where there is x, I put 0 plus y is equal to 8. So my y will equal to 8. So here I'll put 8. Then I ask, what about when y is 0? So I'll say x plus 0 is equal to 8. And our x is also equal to 8. So here I'll still put 8. Then I extract my coordinates 0, 8, and then the next one will be 8, 0. You extract them the way they are. You start with the x, then you write the y. Now, after extracting, we are going to plot. So I'm going to plot 0, 8. So when I come on my graph, allow me to use green. When I come on my graph, 0 and 8 is this point here. Then 8, 0, 8, 0 is a point here. Those are my points. Now, after doing so, I'm going to get my ruler. Get your ruler. And when you get your ruler, you are going to join them. So I'm going to join those 2 points like that. That is my thing. Now, after joining it, then you are going to ask yourself, am I choosing from A? Am I choosing from B? Now you ask, I have this side A, I have B. Members, can we drop a point in the chart, either below in A region or in B region that we can use. Okay, let me look in the chart. Drop 1 point. 3, 4. Daniela Joy has said 3, 4. So where is 3 is here, and then 4 is here. And you can see it is below. So what am I going to do? I'm going to say my testing. Testing. So the point I'm testing is 3, 4. Then I put it, I say x plus y greater or equal to 8. So I replace 3 plus 4 greater or equal to 8. Then I say 3 plus 4, that is 7, greater or equal to 8. Members, let me know through the chat. Is it wanted, unwanted? Put your answer in the chat. Wanted, and Hannah K has said unwanted. Chilabo, unwanted. Everyone is saying unwanted. So meaning that is the region we are going to shade. Very good. So now I'm going to come, I shade that region. So that is the region we are going to shade where we have our A. So I'll shade it like that, like that, like that. I shade it, shade it, shade it, have it shaded. So that is it. Then after, I'm going to label that this line of mine is the line x plus y is equal to 8. Now, after that, we still have other inequality. Other inequality we have, let me fix my things here. The other inequality we have is x is greater than or equal to 3. We say that x greater than or equal to 3, it means that our boundary equation is x is equal to 3. And this one means that our x doesn't change. So it means that when I draw my table, I'll have my x, I'll have my y. So since x is free, for it does not change, your y can be any value, say 1, 2, 3, and the rest of that. So meaning the coordinates we shall plot, we shall have 3, 1, we shall have 3, 2, we shall have 3, 3, and the rest. So when you look at my graph, you'll note that that is the line that is going to be going through 3. So when I come, I'm going to come, let me say this is where I can use, let me use blue. But now let me first do the plotting. So 3, 1, you'll find is here. 3, 2 is here. 3, 3. So something like that, something like that, something like that. Then when you when you draw that line, you'll find that that line is going to come like this. Because it is a vertical line, it will come like that. Yeah, something like that. And then you label it. But now when you look at that line, you can notice that that line, you'll notice that that line already has, let me say, has like all its regions have been shaded. So for it, you don't need to shade, you just leave it there. No, there's nothing you can do because everywhere it is shaded. So, but you can still show that you know what to do, the region that is needed. So now to just show that we know the region that is needed, region that whereby x is greater than or equal to 3. So you ask yourself, which region is greater than or equal to 3? Because that's what they want. So that is the region containing 4, 5, 6, and 7. I don't know whether members, you are not seeing it. Are you not seeing it? Yes. Okay, we are not seeing here. So that is the region that is containing. But one thing now we are going to notice, is that the moment here, I'm going to adjust this question a bit. Yeah, there is something I've noticed. So you're going to notice that what is going to happen is that x, let me use a bright color. Maybe this one. You are noticing that the region where we have x is greater than or equal to 3. That's why we have 4, 5, 6, 7, 8, and the rest. And you notice that this is the region, meaning that if we are to shade, it means that, meaning that if we are to shade, it means that we are going to be shading this region. Are you noticing? And when you shade this region like this, it means that you are not going to remain with any region. So allow me to adjust this question a bit such that we can remain with the region. So what are we going to do? We are going to ignore that statement of at least 3. Alternatively, you are going to let me know what you want. Either we ignore it or we work it the way we are doing. Okay, but let's work it the way it is. So let me shade. So I'll shade like that. That is the meaning. Okay, now after doing so, that is how it has appeared, x greater than or equal to 3. Then we go, now we have finished, but label it. Okay, sorry. Now we are going to label our equation that this is the equation x is equal to 3. Now after that, we go to the last one. Our last ones are x greater or equal to 0, and our boundary line is x is equal to 0. Then the last one is y greater than or equal to 0, and our y is equal to 0. Now, what do you do? These ones, we say that these are the ones where you shade down here. Where you shade down, you shade down, you shade down, you shade down like that. Then you shade this side like that, 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 like that. So that is how you shade. Unfortunately, for this number, we don't have any region that can be bounded. I don't know whether you are getting it. So since we don't have any region that can be bounded, it means that we cannot be able to obtain our answer to that question. So when you go back now here, we cannot be able to obtain C. So here you need to understand now, because they told us that determine the combination of notebooks and pens Mark should buy to maximize the total number of items while staying within his budget. So here you'll conclude and say that since there is no any feasible region, we cannot be able to obtain the maximum amount of items that Mark can buy. That's how you can conclude, since you have not obtained any region. Members, let me know through the chat whether that is okay. Is that fine? Yeah, so that is how you conclude. So here you don't create your own question. You don't create your own question. I wanted to adjust it, but I've said, what if you meet it somewhere? Will you just run away? No. Yes. So here you just conclude, since you have not remained with any region that is unshaded, it means that you don't have a feasible region. So your conclusion can just be that since we do not have a feasible region, then we cannot be able to obtain the maximum or the minimum amount. Okay. Yes, Mark is asking, teacher, have such questions been appearing where there is no feasible region? It has been rare. It is rare, but because that in the new curriculum at times they test for understanding, they may want to test whether you are a crammer or you are someone who understands what you do. Yes, but it is rare and it may not happen. Yes, Patricia.
Yes, teacher, I think Amara is not on the same page.
Amara. Okay. Yes, Amara.
No, teacher, I was just confused on that part when you're talking about if they had not given us. So, teacher, if they had given us a visible region, what would we have done exactly?
Oh, okay. Now we are going to do another number such that it can come out well.
Okay.
Yeah. Yes, Gavanian.
Morning, Master.
Good morning.
Now, Master, when I'm shading my graph in a paper,
Mm.
when I use different colors, do they mark me or they just cross it?
No, they may not penalize you, but I'm just wondering where you'll get the different colors. So I advise use one color such that your work is very neat. So here I use different colors just because I want to show you the different lines.
Thank you, Master.
Chisache Mark.
Yes, teacher. So if I had used a different scale, wouldn't, let us say if we were having a feasible region, wouldn't the region be larger, and wouldn't I get maybe different optimal points?
No, even if you use a different scale, you'll end up with the same answers. That is the beauty. Is that fine? You end up with the same things. Okay, now let's go to the next question. Write this question. It's what we are going to do. Put in the chat, let me hope you have read through. Put in the chat, what is your X and what are you going to let to be your Y? Put in the chat. Put in the chat, what is going to be your X and what's going to be your Y? Okay, people are saying lorry X and pick up Y. Okay, pick up Y. Very good. Okay, I think we are good to start. Okay, now we said always first let, and the first thing they mention, let it be your X, and then the next one is your Y. So I'm going to say that I'll say let X represent the number of trips, for you write the whole word, the number of trips to be made by the lorry, and let Y represent the number of trips to be made by the pickup. That is the opening statement. We call it where the marks are going to start from. Now, after doing so, I told it it's always a good practice. You can first have your simple table summarized. In your table, what are we going to have? We have two things. One, we are going to have a lorry and we shall have a pickup. Now, you read through. They told you that these pickups are going to be carrying bags. So here, I can say bags. And when you look at our lorry, can carry 90, and the other one can carry 20. But the total number of bags they want to take are 240. The total number. Then what about the cost per trip? The cost per trip, this is the cost per trip. So the cost per trip, a lorry charges 50,000. A pickup charges 15,000. But how much does the person have? The person has 180,000. Now, after you summarizing your data like that, not everything you have in the question, you can have it summarized in the table. So there's like now this statement, the pickup makes more trips than the lorry. Now, like for such a statement, you may not be able to summarize it in the table. So, but you must have it somewhere. So now we extract the first one. Part A, the number of bags to be carried. You write that inequality. And what inequality do we have? They have told us that at least 240 bags, meaning that the number of trips the lorry and the pickup are going to make must be able to take the 240 bags. So now I'll say 90x plus the 20y should be greater than or equal to 40. Then part B, the other inequality, the cost per trip. The cost per trip. Now the cost per trip, still I go back. What will I have? I'll have 50,000x plus the 15,000y. Since they told you that he has, we have said that when they tell you that that is the amount he has, it means that that is like the max, it shouldn't exceed that. So meaning that here we shall use less or equal to 180,000. Members, let me know through the chat. Are we still on the same page? For those two inequalities so far written down? Okay, Doreen says yes. Okay, yes, very okay. Then we go to the next inequality. The next one is from here. The pickup makes more trips than the lorry. Can you write for me that inequality in the chat? What you think? The pickup makes more trips than the lorry. Can you write it and we see? More. I want to see which inequality you're going to write for more. People have started putting their answers. Chisach has put, Patricia has put, greater than Olive, Daniela. Okay. Yeah. Now the inequality we are putting, yes. So when they say more means greater than. There is no equal. So it means that we shall have pickup is y greater than x. Now, after that, the last inequalities, we are going to say that we cannot have negative trips. So we shall say the non-negative trips. Or you can say inequalities. There is no any problem. So those inequalities, we shall say x is greater than or equal to 0 and y is greater than or equal to 0. Then the other inequality we can put can be the one for objective function. Now, the objective function is the one that you are going to use to find out how much money you are going to use. So that one can be there. We call it the objective function. Your objective function. And now that objective function, it is the cost you are going to incur in transporting. So that one will equal to 50,000x plus 180,000y. Members, are we together? The one that you are going to use to find out how much you are going to spend depending on the number of trips that have been made. Is that okay? Kindly let me know through the chat. Are we together on that? Doreen is asking, is it a must write it? I will say it is always a good practice. It shows that you understand that we cannot have trips that are negative. So that's why we include it there. For whatever number you do, include them there to show your understanding that always you cannot have trips that are negative or quantities that are negative. That is the meaning. Yes, Olive.
Good morning, sir.
Morning.
Sir, here when you was writing the objective function, where you have made the cost x, y, I think it is equal to... Have you seen the mistake, sir?
Yes, this is supposed to be 15,000.
Yes.
Okay, thank you. So
Welcome.
this is 15,000. Okay. Okay, I think we are good. Yes, OJ, you are right. Okay, now the next thing I'm going to do is that I want to reduce on those inequalities. Because now the next part we are going to do is plotting. So we reduce them together. So I'm going to come. In case you don't, we have 90x plus 20y greater than or equal to 240. So in case I want to reduce them, you can get your highest common factor. that one is okay. In case you want, you can say 90, 20, and then 240. So you say which figure can I start with to divide? Then you know maybe I can start from 10. I can start. So in case you want, you can say, let me start from 10. I'll have 24. I'll have 9. I'll have 2. Then you ask, is there another thing that can go through? That it can go through all of them at a go? You may notice that there is nothing. So meaning that your highest common factor is 10. I divide by 10, by 10, by 10. So you're going to notice that once you divide by 10, the 0 will go. This 0 will go. This one will go. So you remain with 9x plus 2y greater than or equal to 24. So you may not be able to proceed from there. Then come to the next one that you want to reduce. The next one we want to reduce is the one of 50,000 x plus the 15,000 y, less or equal to 180,000. So here you notice that it has 3 zeros, 3 zeros, 3 zeros. So in fact, so I can first divide by 3 zeros. I'll get 50x plus 15y less or equal to 180. Then ask yourself, is there any other thing that can go through? Surely, yes, there is. So take an example, 5. So when you divide by 5, by 5, by 5, by 5. So by 5, you get 10x. Here you have 3y less than or equal to 180 by 5. I think that is 36. Kindly confirm whether it is 36. Yes. Okay. Now that is what you are going to get when you reduce. Members, are we still together on that? As I answer Joan. Yes, Joan.
So for me, my question is it a must to have the non-negative inequalities?
Yeah, yes, what I've said about the non-negative is that non-negative, they show you that you cannot have negative trips. That is the mathematical interpretation. That for any number of trips you are making, you cannot have what? You cannot have a negative.
Okay.
So always there are positive. So always you write them there.
Thank you, sir.
All right. Okay. Members, are we on the same page? Okay. Okay. It seems okay. We are on the same page. Okay. Now we are going to go on to the next part of us drawing our graphs. Okay. Now this is my screen and we are going to draw our graphs. Okay. Now on my graph, I'm going to start with the first one. And the first one, I think I can start with the first one. Okay. So the first one I have is going to be, which one should I start? Okay. I can start with the one of 10x plus 3y is less than or equal to 36. Now I'll come here, I'll have my x and y, but I first write my boundary equation. So my boundary equation is going to be 10x plus 3y is equal to 36. Now I ask myself, what happens when x is 0? I'll come back in my equation. I say 10 times 0 plus 3y is equal to 36. So I'll have 3y is equal to 36 by 3 by 3, and my y will equal to 12. So here I'll have 12. Then I ask myself, what about when y is equal to 0? So when y is equal, I'll have here 10x plus 3 times 0 is equal to 36. This will give me 10x is equal to 36. Divide by 10, divide by 10. So my x will equal to 3.6. So when this is 0, here you have 3.6. However, like yesterday I said that when you find yourself that you have some points, in order for you to be exact, not to gamble with the points, you can increase on the number of the x values. So take an example, you can have another x value. Let me say you have 2. So you look out for other values that can give you an exact number in simple terms. So now when I use 2, I'll have 10x plus 3y is equal to 36. So when my x is 2, I'll have 10 times 2 plus 3y is equal to 36. So this is 3y is equal to 36 minus 20. What do we get? So 36 minus 20, that is, does it give us an exact number? Or it doesn't? So in case it doesn't, then that one you can ignore it. Yeah, because you can look at when we have here, it does not. It does not. Yeah. Instead, allow me to change. Instead of having, I wanted something that gives us an exact. So when you look at 2, 2 is not going to give us an exact because I'm saying that it's going to be 16. So allow me to ignore this one. And then I can use another one. Another one I can use. Someone can put for us the chart. What you think can give us an exact? I have seen another one that I can use. 16 out of 3. Just drop it in the chat. Okay, for me, I can use, when I use my x as my x, let me say I use, when I use my y as a 2, when I use my y as a 2, you notice I can have 10x plus 3y is equal to 36. So this will be 10x plus 3 times 2 is equal to 36. So this is 10x plus 6 is equal to 36, which will have 10x is equal to 36 minus 6. So 10x will equal to 30. And now our x will equal to 3. So I can have that one. Yeah, hope that is clear, members. You can look out for a digit which will give you an exact value. So surely you can use that exact, yes. Yeah, it is always better when you have exact points because some of you at times will find challenges plotting the points. Then after, I'm going to extract my coordinates. I'll say 0, 12, 3.6 and 0, and then I'll have the 3 and the 2. In case you have other values, you add them. It is very fine. Then after doing so, I have to go on my graph and I plot. And I plot. So I'll come on my graph here. Then I draw my line, that this is my line. Then I'll come here, I draw my horizontal line. Then you put all the qualities we have said about a good graph. So I'll come here, I label that this is my x-axis. And along the x-axis, we call those the lorry. So here I'll say number, you write in words, number of trips made by lorry. Then this side, we shall say number of trips made by the pickup. So make sure for you write in words, please don't write NO for you complete. Then what do I have? A title. So I'll say a graph showing the feasible region between the number of trips, for you to complete the number of trips made by the lorry and then the pickup, or number of trips made by the pickup and the lorry. Then the next one, we must have a scale. So you must have a vertical one and you must have a horizontal scale. Another thing now when you look at the values I want to plot, you're noticing that my y must reach out on 12. But since when you look at my graph, I don't know whether I'll be able to reach the 12. This is 0. So let me say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Me, I can only stop at 10. But since I want it to fit, I don't know that you can allow for me to use 2, 4, 6. This is 8. This is 10. And this is 12. Now, since yours is big, feel free to use 1, 1. It is very okay. Since yours is big. But I will show you another. Then here, I can still say for the X, so far I'm saying my values look to be a bit small. They're not so big. So I can as well decide that to be safe, let me first use 2, I use 4, I use 6, I use 8, I use 10, I use 12. Like that. That one is also very okay. Now, if this is the scale you're using, but for you can use 1, 2, 3, 4 up to when you reach 12. 1, 2, 3, 4 up to when you reach the last one. That is very okay, members. Are we together? Even it is okay. Allow me to first draw the second one such that I can know how far I have to go on X. So I can have 9X plus 2Y is greater than or equal to 24. That was our second line. And our boundary line here is 9X plus 2Y is equal to 24. Now, when I have my table here, I'll have my X and Y. Then when X is 0, you are noticing that my Y is going to be 12. I don't know whether members have noticed that. Kindly confirm. Kindly confirm that. Then you ask yourself, what about when Y is 0? When Y is 0, I'll have 24 divided by 9, which is 2.667. Now, for such a case, you write to one decimal place. So here I write 2.7. But like I've said, look for other points which can help you or which can give you a whole number. So members in the chat, you drop any point you feel is going to give us an exact figure. Drop it in a chat any that you feel when we substitute it is X, we shall get an exact. Okay. Cynthia is saying 2. Someone is saying 3. Okay. Okay. Now for me, I can start with the 2. When I drop here a 2, you notice that I'll have 9 times 2 plus 2y is equal to 24. So this will be 2y is equal to 24 minus 18. So 24 minus 18 will give us a 6. So 2y will equal to 6 and y will equal to 3. So here I can have my 3, which is very okay. Yeah, so those ones are enough. So when you notice that my X values are a bit small, 0, 2.72. Now here on my scale, it is okay even to say that my scale along this side here, I can go on and use, okay, I want to erase something. Here, people were asking, can we use different scales on both axes? We can apply it here such that you can get it. So here I can decide to say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. But still, when you look at it, your graph may be very small. For you can say, no, for me even I want to jump to 2. Then I will come here and I say, let me remove this. For me, let me jump 2. And I say that this is going to be my 1, this is going to be my 2, this is going to be my 3, this is going to be my 4. So you are noticing that I have jumped. Every after 2 centimeters, I have 1. Every after 2 centimeters, I have 1. Every after 2 centimeters, I have 1. Members, let me know through the chat whether that is very okay. Kindly let me know. Are we on the same page? Okay, people, Sachi says yes. Yes, we're on the same page. Okay, very good. Now, I start plotting 0 and 12. Allow me to use another color. 0 and 12. So 0 and 12 is here. I'll put there. Then 3 and 2. 3 is here and 2 is here. Then I go to 3.6 is my x. Now, when you look at my value here, you are noticing that I have put here 3 and this is 4. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 3.6, this is 3.1, 2, 3, 4, 5, 6. So 3.6 is here. So when I go where there is 3, 3.6 is going to be somewhere here. So I'll plot that point. Then after plotting, you notice our lines are bold lines. Then I'll just come here. I draw that line like that. It will come like that. Then after drawing that line of mine, I'm going to go on and I label my line. But I first shade. Now members, you're going to let me know where are we going to shade. So I have A, I have B. Drop a point in the chat that we can use to test. Drop a point in the chat that you want us to use to test. Either in region A or in the region B. Any point, 1 and 6. Joy has said 1 and 6. So we shall go with the first person, 1 and 6. So since they have told us 1 and 6, I'm going to come here in my region. Allow me to remove this. And I say now it is time for testing. So I'll say testing for the region. Testing for the region. So they gave us 1 and 6. Please never choose a point on the line. So 1 and 6 is a point somewhere here. So I'll come and I say my equation I'm testing is 10x plus 3y less than or equal to 36. So I substitute. So this is 10 times 1 plus 3 times 6 less than or equal to 36. So this is going to be 10 plus, then I multiply. What do I have? 3 times 6 is 18 less than or equal to 36. So 10 plus 18, that one gives us 28 less than or equal to 36. Members, is it the wanted and wanted? Put in the chat, wanted and wanted. It is the wanted. So being the wanted region, we shall not shade it. So we are going to shade the other side like that, like that, like that, like that, like that, like that. And then I'm going to label that this is my equation, 10x plus 3y is equal to 36. Now, after drawing that, I go to the next one. Here, our points we are going to plot, we have 0, 12, I have 2.7 and 0, and then I have 2 and 3. So allow me, I'm using different colors such that I can have distinguish the lines. So 0 and 12 is still here. Then 2 and 3, 2 is here, and now my 3 for y. Now, remember I have used the scale, for me here, I've used a scale of 2, 2, meaning that here my 3 is going to be in the middle here. So I'll come and I say this is 2, my 3 is going to be in the middle here. So it will be somewhere here. But now, since some of you have used the 1, 1, so please for you go on and use what you have. Then 2.7 and 0. This is 2.7 is here, and then the 0 is here, like that. Then I'll have to come, I ask the nature of this line is a full line because we have greater than or equal to. So I'll come here, I get my ruler, and then I draw a line. Now, when I draw a line, my line will look like that. Something like that. Yeah, it will be like that. Then still, I go back. Now, when I go back, I'm going to ask myself, which region am I going to shade? Am I shading A, B? So members, this is our A, B side. Drop a point in the chat that we can choose from. Favor said 1 and 4. 1 and 4. 1 and 4 is the point here. So it's the one we are going to use for testing. So I'll have 9x plus 2y greater than or equal to 24. So our point is 1 and 4. So I say, this is 9 times 1 plus 2 times 4 greater than or equal to 24. This is 9 plus 8 greater than or equal to 24. Then I ask myself, what is 9 plus 8? It is 17. So 17 greater than or equal to 24. Then you ask yourself, is it wanted, unwanted? People have already said it is the unwanted region. So that is the region we are going to shade. So members, I'm going to come and then I do like this because it is a point down. So I'll do like this, like this, like that, like that, like that. But remember, I have to label my line. So I can write somewhere here, or I can write somewhere here that this is my line. 9x plus 2y is equal to 24. Yes. Okay, members, may I know through the chat whether we are still on the same page? Are we still on the same page? Okay, very good. We are still. Now, after that, I go into the next one. Now, the next one I have is going to be the one for x greater than y. That is the other one. So is it y? Y greater than x. Allow me to write it here. Y greater than x. So our boundary is y is equal to x. But when you look at it, for it, you are going to notice that here, our line is going to be a dotted line because we don't have an equal. And here, your x and y values are the same. So in case this is 0, this is going to be 0. If this is 1, this will be 1. If this is 2, this is going to be 2. If this is 3, this will be 3. Meaning that our coordinates we shall plot will be 0, 0, 1, 1, 2, 2, 3, 3. So allow me to plot 0, 0, now 1, 1, 2, 2, like that. So you'll notice that I have to plot 1, 1, 2, 2, 3, 3. So if this is where my 1 is, my other one is going to be here in the middle. But now I know if you use the good scale, please, it must not be able to disturb you. Then you have the 2, and then the 2 is here. Then you'll have 3 is here, and my 3 is another 3 is going to be here. Then I have the 4 and then the 4. So my line will look like that. But since we have said it's going to be a dotted line, you are going to allow me, there is something I have to do here because I know I'm going to, okay, allow me to first use, I want to first use, it is a dotted line, but I'm going to dot it. I'm going to dot it, don't worry. Yeah, I want to first trace such that I can get a good straight line. Yeah, so, but make sure yours, you dot it. So this is supposed to be dotted. So allow me to, I don't know whether I want to dot it. So you dot it, it's supposed to be dotted. I'm going to dot mine. Don't get worried. Yeah. I'm going to dot mine. I'm going to dot mine. Okay, mine is there. It is dotted. So make sure also yours is dotted. And I'm going to label that this line here is my line. X is equal to y, or y is equal to x. Then I'm going to choose a point. Either I choose it above or below. So I have A is up here, B is below. Members, can we put a digit in the chat? Patricia has put 3, 2. 3 and 2. So 3 and 2 is somewhere here. So it is below. So I'm going to say 3 and 2. I test. Our inquiry was y greater than x. I ask myself, I'm going to ask, my y is 2 greater than 3. Is it the wanted, unwanted members? Wanted, unwanted. Put in the chat. Is it wanted, unwanted? Unwanted. Very good. So this is the unwanted region. So we shall shade our graph like that. Yes. So allow me to shade it like that. Yeah. Okay. So we have finished to shade. And now when you look at our graph, the next ones we are going to do is y greater than or equal to 0 and then x greater than or equal to 0. So for those ones, it's just a matter of us shading the other part. So now for those ones, you just get your ruler and then shade, much as they are being covered already. So, but you can shade them to show that you really know what you are doing. So I just shade like this to show that I cannot have non-negative. Also down this side, I can shade to show that I cannot have a non-negative. Members, may I know whether the graph is very clear to everyone, whether we have understood, whether we are good to continue? Let me know through the chat. We continue. Now, when you look at our graph, we have remained with what we call a feasible region. Now, that region you are seeing is what we call the feasible region. And that region is the one that is going to dictate our solution to the equation. But there is one thing we are forgetting, is the scale, right? We are going to write our scale. But when you are writing, please base on what you have. Like I've said here, I use the different scale. Some of you use the different scale. Go to the vertical. So on vertical, you're noticing that 1 centimeter is representing 2 trips. I will say 2 trips made by the pickup. That is the meaning. Then here you are noticing that on the horizontal, you are noticing that 2 centimeters are representing 1 trip made by the lorry. Yeah. So members, is that fine? Is our scale okay? Okay. Favor said yeah. Yeah. Lydia said yeah. Okay. Very good. Patricia, yes. Okay. Now, after that, we are going to extract the points from this region. But like I told you, when we are extracting the optimal points, always first look at the corner points. The corner points are the ones that are always the ones that can give you the maximum or the minimum. But now when you look at this graph of ours we have, you notice that the corners, this is one of the corners I have. Another corner I have is here. Another corner I have is here. That are forming that thing we talked about, the region, the bound region. But when you look at them very well, you notice that this corner has a dotted line. This corner has a dotted line. Members, since dotted lines are not part of the solution, we are going to ignore those corners faithfully. Don't use them because they are not part of the solution. One of the point is not part. So one of the points we are going to extract, this is going to be one of our first points. And you must read the coordinate of that point, members, in the chart. What is the coordinate? What is that coordinate I've shaded? 0, 12. Thank you, OG. Now we have picked one point. Now, after that point, now since we cannot, I've told you must have many other points. I want you to look in the chart. You look in your region and keep extracting points within the region or along the line. So let me extract some. So I can look here. I've said 5 points and more are good. So I can have this. I can have this. I can have this point here. I can have this point. Now, those who are accurate, even if the point is touching and you can read it off, most so we deal with integers here. We don't deal with points. So members, extract them. Extract them. It must be a point within, and you must be able to read it. Don't extract points you cannot read. Yeah, so look through and extract. We want 5. So for you, I've extracted for you. This is one of them. Another one I can extract. Let me say I have, You notice even this one, I can extract it. Even when it is on the line, it is very okay to extract it as long as you can read it. I've extracted, there is this one, there is this one. This is 2. Can I read this one? I can read this one here. Yeah, so extract them. Put in the chart all the points for you are seeing on your graph. Make sure that point is on the line. People are extracting. Put them in the chat. I'm going to pick all the points. And members, I want to leave this screen here. Put all the points you are seeing. But they must be within the region. We have said that we only write integer values. Integers, we don't have points. So I don't expect you to write 0.3, 0.2, and the rest of that. No. We can't have 0.3 trips. It means someone stopped in the middle. He didn't reach. So someone must make a full trip. So do not extract those points. So, okay. 1836. Very good. 1224. That is okay. Members, can I move to another screen? Let me know through the chat. Can I go to another screen? Let me know. Can I go to another screen? People are saying, yes, you can go. Okay. Now, allow me to go to another screen. I wanted to just show you how mine came up when I used the graph. So mine came out like this. This is how it came out when I used the graph. It came out like this. But here you notice that I used another scale different. So it came out like that. So if yours is coming out like that, that is very okay. Yeah, that is very, very okay. Do not worry. It is very correct. So that is very good. That is very good. So I come back here in peace. Now I'm going to draw my table, depending on the points you have extracted. Okay. So I'm going to draw my table. And in my table, when I'm drawing, I'm going to call them optimal points. Optimal points. And those optimal points is what I have as my X and Y. Now, since they are my X and Y, one of the points we extracted was 0 and 12. Another point I have seen in the chat, people have put 1 and 8. Another point I saw in the chat, I saw 2 and 3, but I also saw 2 and 4, if I'm not mistaken. I also saw 2, 5. Those are some of the points I saw in the chat. Then we are going to go back and ask what was our objective function. 3 and 6. Members also saw 3 and 6. But let me confirm 3 and 6 from my graph here. 3 and 6. Is 3 and 6 on the graph? It seems 3 and 6 is out. Because if this is my 3, looking at this graph, 6 is here. 3 and 6 is here. Look through it. On my graph, it shows it is out. No, yeah, it is out. Okay. So 3 and 6 is out. So allow us to remove it. It must be within the region. Okay. Now, these are some of the points that we have. Now, we go back to our equation, what we call the objective function equation. And that equation told us that the cost for the transport would be 50,000 of X plus 15,000 of Y. So it's what I'm going to put here. I'll say cost X in terms of X and Y is 50,000 X plus 15,000 of Y. Now, after getting that, it is time now to work out. Now, when I'm working out, I substitute. This is my X and this is my Y. So I'll say 50,000 times 0 plus 15,000 times 12. So you do your mathematics that this is 0 plus 15,000 times 12. So 15,000 times 12, I'll get 180,000. So meaning that here, if for you want, you can even put here that this is 180,000. Then go to the next one, 1 and 8. Substitute 50,000 times 1 plus 8 times 15,000. Then do the mathematics that this is 50,000 plus, then you say 8 times 15,000, that is 120,000. Then say 120,000 plus 50,000, that is 170,000. So for that pair, we shall have 170,000. Members, complete for the rest. Complete for the rest. And put in the chat the answers you are getting. In case you are stuck somewhere, feel free to raise up your hand. Yeah, in case you are stuck. But I expect now, put for me the answer you are getting for 2-3. Then after that, you put for me what you get for 2-4 and then 2-5. Okay. Aine, are we on the same page? Aaron, are we on the same page? Lily, are we on the same page?
Yes, sir.
Bernard, Blessing, Brenda, Caroline, are we on the same page? Yes, Desire?
Same page.
Okay.
So good morning, sir.
Yes, good morning.
Yes. I wanted to ask that, yes, maybe the dotted line, it wasn't a dotted line. Which points would we pick?
Yeah, we would also consider those points in the corner.
Okay.
Like when you look at this graph of mine, we would also have taken that point and that point.
Okay.
Okay. I was checking on people here. Kathy, are we on the same page? Caroline, Cynthia,
Yes, sir.
Christina, Joy, Daniela.
Yes, sir.
Yes, teacher.
Okay, Hunter, Hope, Anake, Gavanian, Joel, Joshua,
Yes, teacher.
Joy, Joyce, Jonah.
Yes.
Yes, teacher. Okay, that is good. Yeah, that is good if we are on the same page. Yeah. And for these things to stick very well, practice will do us well. Okay, I'm waiting for the answer in the chat. Hey, people have put the answer. Okay, I'm happy. Hunter is very active. Hunter, thank you. I'm writing Hunter's answers. So in case there is anything you're doubting, please, I'm using Hunter's answers. Okay, I think that is what people have, and I feel members are agreeing with the answers. Yeah, looking at what everyone is getting, Chilabo, Doric, Favor, Alan, Olive, it seems people are agreeing. Daniela, Joy, okay, Patricia, Bernard, I think you are agreeing. Now, after that, we are going to go back to our question. Our question will ask us part C. Use the graph to find a possible number of trips to be made by the lorry and a pickup. Hence, find the minimum cost of transporting the bags of sugar. Now, members, we have to reason now. When you look at the amount we have, what pair gives us the minimum amount? You raise up the hand and then you let us know. Here, because we want to reason, you let us know. Which pair is giving us the minimum amount? Okay. Okay. Yes, Mal? Oh. Mal? Oh. Mal is not talking.
The pair 2 and 3.
Which one? Okay, the pair? Etho? Oh, people are not talking. Favor, I'm seeing your hand up.
It's 2 and 3.
It is 2 and 3. So when you look at the pair, this pair here, it's really giving us the minimum amount. Now, after that, you go back and look at your conditions. They told us that y must always be greater than x. So when you look at the pair we have chosen, does it satisfy that condition, members?
Yes.
It does, eh? Very good. Then that means that that is the pair that we shall take. Now we go back and now answer the question. Now, always when you are answering, make sure you answer to satisfy the person marking you. Now, I want someone who can give us a good conclusion. If you feel you can give us a conclusion, let us start. I want a conclusion, how you are going to conclude. Yes, Gavanian, we can start with you. We are responding to the question. Yes, Gavanian? Oh, yeah. I want us to respond to the question, this question here. Find the minimum cost of transporting the bags, the number of possible trips, and then. So I want to hear some response. I don't want to give you mine.
Excuse me, sir.
Yes.
I'm sorry, but may I just had a question?
Yes.
I'm asking, or I would like to know the more about simultaneous linear equations.
You wanted to do what?
More about simultaneous linear equations.
How to solve them and the rest?
Yes.
Okay, I'm going to respond to it at the end of the lesson.
Okay.
Okay. Now, okay, Chisachi, are you concluding?
Yes.
Okay, conclude.
The possible number of trips to be made by the lorry are 2, and those to be made by the pickup are 3, and the minimum cost of transporting the bags is 145,000 shillings.
Okay, good. That is a very good conclusion. Yes. So we shall say, because the question started with the possible number of trips, so we shall say that the possible number of trips that can be made by the lorry are, I don't know, lorry was what? Was X, yeah, are 2, and then the ones to be made by the pickup are 3, and the minimum amount or cost of transporting the bags of sugar is 145,000. That's how you conclude. Yes, do not just write there 2, 3, 1, 4, 5. That one doesn't make a sense. You are not communicating. Your conclusion must be able to communicate. That someone reading it must be able to understand what you have put down. Yes, Olive.
Okay, sir. What I'm asking. I'm saying my power is not okay, but let me ask this question before going off. If they have asked the maximum cost of transporting the bags of sugar, on that question, how can we do it?
Now, still, if they had asked for the maximum, of which here we always, the maximum, here you look out for the biggest figure you have. So the biggest figure we have is 180,000. Are you seeing it?
Yes, sir.
So, yes. So that is the biggest figure. So in other words, if you are budgeting, it means that in your pocket, you must have at some 180,000. So asking maximum, they are looking at your planning skills. That if you are planning for you to do those deliveries, how much should you have within in your pocket? So you look out for the pair that is giving you the highest figure.
Yes, but now I remember we had one say that x is greater than 0, cannot be equal to 0.
Where did we have
so
it?
now if we are doing that one,
we said x can be greater than or equal to 0. So it means that you may
Okay.
decide. So when we have 0 and 12, remember these are lorry, these are, is it pickups? Now this one means
Yes.
that you have decided to only use a pickup and not use a lorry. That is the meaning when a lorry is
Okay.
0. So it means that the lorry is going to make no trip, but you have decided that I will save more if I use only pickups than combining the two.
Okay, sir. Thank you.
All right. Okay. Okay. Members, are we on the same page for that number? Yeah. So always, but I want you to refer back to your inequalities. When you are reasoning, you are concluding, look at and weigh the inequalities that you have. Yes, Marie. Marie and Mark.
Yes, teacher. Now, what if we are having two coordinates that are giving us the same, let us say we want the minimum, and then two coordinates are giving us the same amount. Which coordinates would we take?
Now, Mark, that is very possible, and thank you. Now, what happened is that you go back and look at the condition. You go back and look at the what? At some of the conditions from the inequalities. You may find that 2 and 3 are giving you, or 3 and 2 are giving you the same thing. But when you look at the inequalities you have, the constraints, which one satisfies? Sorry, I had forgotten to plug my router in power. Okay. Yes, Maria, your hand is up, but you are not saying anything. So I want you to take a screenshot of this question. It is one of the items you are going to do for me. Yes, Maria?
Yeah. Good morning.
Yes, good morning.
Tell me, I'm still confused about the vertex thing. Because I thought the vertex was just the cone.
Yes, you thought?
I told the vertex, like you said that, find the coordinates of each vertex of the feasible region. So I told that the vertex is like in the corner part, but then I saw you picking like from other parts also. So could you please re-echo on that?
Like we said, I want you, there is something I mentioned that we said vertex.
So in the graphical solution set, okay, like those instructions you gave us at the beginning, the second step is that find the coordinates of each vertex of the feasible region.
Okay, now what I meant, I say that in most cases, it is the vertex, those corners, that will yield either the maximum or the minimum, but they may not give you the both. So when we look at the question we have been dealing with, you notice that it was at the vertex where we had the maximum, not so? But the question wanted the minimum. Are you getting it? But since this corner here, these corners we had here, these corners had a broken line. That's why we did not take them. But you have noticed that these corners here, if you choose a point on these corners, you'll find that the amount you are getting is very small, is the minimum. But since they are dotted, then we cannot use them. But you have noticed that the point we have obtained as our minimum is very close to these two corners.
Okay.
So it would only apply if this was the borderline. You'd find that our minimum would still be at that vertex.
Okay. But teacher, when you're picking the points, do you pick them from like the feasible region part?
Yes, you pick from the feasible region, and the feasible region is bounded. So you look at the area that is being bounded. That is where you pick from.
Okay.
Okay. So members, take a screenshot. This is the item we are going to do. This is the item we are going to do today. I want to give you two, hoping that your time will allow. Okay, I hope you have taken a screenshot. And this one. Okay, so those are the items I want you to try in your free time today, and then we shall start from there. So tomorrow we shall do other items, and then we proceed. So when you look at this here for this particular one, the thing that I'm interested in most is seeing how members are going to interpret this statement here. It's my major interest, that one. Okay, so we are going to end here. Let me wish you a good day. In case you have any question, feel free to ask now. But if we do not have, we are going to end